This video is going to look at polar coordinates, where we're going to start looking at the polar coordinate system. And before we do that, we want to go back and look at up to this point where we've used the rectangular coordinate system, where we would use our x and y axis here. So for example, recall if we wanted to plot the point, let's say 2, 3. We know that the 2 is our 3, the 2 is our x value and the 3 is our y value. So we have the ordered pair x comma y. So that would tell us we want to go 2 units in the x direction and then 3 units in the y direction, and we end up with our point here. So now we're going to look at the polar coordinates, and when we do that, we're going to have our center part here, which we could sometimes refer to as the origin, but usually here instead of the origin we're going to call this point the pole, since we're looking at polar coordinates. And we're going to rotate from this distance around some angle theta, which will be our directed angle, and that simply tells us how far we're going to rotate around to get to our point. And once we rotate some angle, then we're going to go out some distance r, which would be the directed distance, and that's going to tell us to go out how far to get to our point. So over here where we used x and y in the rectangular coordinate system, over here we're now going to be using r and theta. So instead of having the ordered pair xy for the polar coordinates, we're going to have r comma theta. So let's look at an example here of how we can plot points using this r theta in the polar coordinate system. So first of all, I'm going to go ahead and draw out our coordinate system here. And I'm going to actually draw some circles here. And each circle, the first one is 1 unit out, the next one is 2 units, and we draw another one here that'll be out 3 units. And now if I give us the point that we want to locate is 2 and pi over 3, okay, and keep in mind now this is r comma theta. And typically what I do is, instead of looking at r first, I look at the angle theta, which in this case is pi over 3, and that tells us that we want to go around pi over 3. So if you go to your unit circle, or we recall, where is the angle pi over 3? So we're going to start here on what we normally would classify as the x-axis, but we want to rotate around pi over 3. And if we do that, we know that pi over 3 is going to be roughly right about here is the location of pi over 3. So keep in mind this point right here is the pole right at the center. So you can imagine if you were standing right here at the pole or the origin, and imagine that you're facing this direction here, and if you want to turn yourself pi over 3, you would turn to the left until you're here at this angle of pi over 3. Now you can imagine that you are facing in this direction here of pi over 3, and now you want to actually go out a distance of 2. So basically you want to take 2 steps in that direction. So you'd go out 1, 2, so each circle represents 1. So this point would go out 2 units to here. So that would be plotting the point 2 comma pi over 3. So once again, we're going to rotate around to pi over 3, and then we know we want to go out a distance of 2 because r is equal to 2. Now, what would happen if, let's say that we had the point -2 for pi over 3. And once again, I'm going to start with the angle. So if we're facing here to the right over here, and we want to rotate 4 pi over 3, well, you go 1 pi over 3, 2 pi over 3, 3 pi over 3 is over here. So then 4 pi over 3 would be located here. And now imagine again here, we went around all the way around here to 4 pi over 3. So again, if we're standing at the pole, that means we're facing this direction down to the left. So if we're facing down this direction from the pole, we now have an r value of -2. Well, that tells us that we want to, instead of going forward 2 steps, we want to go backwards. So again, imagine if you're standing here facing this direction, the -2 says we're going to go in the opposite direction. So that means we're going to go backwards 2, which is actually going to put us right here at the exact same location as the 2 pi over 3. So what we noticed here is we can actually have 2 points, 2 pi over 3, -2, 4 pi over 3, and that will give us the exact same location here. And that's because we can rotate around different angles and have different values for r to put us in the exact location. And recall though, when we worked with the rectangular coordinate system to find this point, there's only one x and y value to get here, which is 2, 3, over 2 and up 3. Whereas with the polar coordinate system, we're going to discover that we could have an infinite number of points to get to this particular location. For example, I could use 2 and I could look at a -5 pi over 3. So once again, we're going to kind of face over here in this direction. And now because it's a negative angle, we're going to rotate around this way until we get to a -5 pi over 3, which is going to be the exact same location here. This would still be a -5 pi over 3. So once again, we're facing this direction. And then again, we have a +2. So once again, we're going to walk out 2 places and we will be here at this same point. So here, the blue, the red, and the green, these coordinates would actually put us at the exact same location on our coordinate system. Okay, let's look at one that's a little bit different. What if we had, say, 2, 4 pi over 3? Well, once again, we're going to face the angle of 4 pi over 3, which is down here. So we're facing this bottom left-hand corner. But now, unlike the example here where we had a -2 in red, we have a +2. So that means we're going to step forward 2 units, and that would put our point at this particular location. And once again, if I was to look at the point -2, pi over 3, where pi over 3 is facing up here to the upper right, and because it's a -2, we would step backwards 2, and once again, we would be here at this same location. So I think you're getting the idea, hopefully, that we can use multiple coordinates to get to this same location. Now, most of the time, if we're going to label the point, we probably want to use typically a positive r value, and we want to use the smallest positive angle typically. So if I was trying to get to this point here, up here, that's 2 pi over 3 at this location, I would probably use this one here in blue as opposed to the red because you have a negative r value, and then for the green we have a negative angle. So I would usually elect to use the positive r value with the smallest possible angle that is positive. Now that doesn't mean that you can't use any of the others, but keep in mind it's r comma theta. All right, I want to look at another example of this type, and maybe you can at the point pause the video and see if you can actually find the location here. So let me go ahead and draw out a little bit of a coordinate system here. So here's 1 unit out, 2 units, and 3 units. So let's start with the point 1, pi over 2. And once again, keep in mind this is r comma theta. Now again here, at this point, pause the video and see if you can actually locate this point. So first of all, again, I'm going to start with the angle, theta, pi over 2. So hopefully we realize that pi over 2 is going to be here at the top. We're going to rotate this way pi over 2. And now we have r value is 1. So if we're facing up here in the direction of pi over 2, that means we want to take 1 step forward. So we're going to go out 1 unit to this point here. And let's see, if I have the point -3, 0, well, that means we're going to face the angle of 0. Well, that means we're facing right here in this direction to the right. So if I'm facing this way, and then we have -3 as the r value, that means we're going to go backwards 3. So if we go back 1, 2, 3, we would be at this point here. And if we look at another point, let's say that we have the point 2 comma, whoops, 3 pi over 4. Again, we're going to locate where is 3 pi over 4. So if we start here and rotate around, this would be 1 pi over 4, 2 pi over 4, and all the way to here, this would be 3 pi over 4. And then from here, we need to determine how far do we go out. The R value is 2, so that means we would go positive 2 in that direction that we're facing. So we would go 2 units in that direction. So keep in mind, the positive and negative has nothing to do with necessarily going left or right. Positive means we're going to go in the direction that we are facing the angle. The negative means we're going to go in the opposite direction that we're facing the angle. And let's see, what if we had, say, the point 0 and 6 pi? Well, first we'd locate the angle of 6 pi. So we know that if we go all the way around this way, this would be 2 pi. And if we went all the way around again, we would have 4 pi. And all the way around again, we would end up with 6 pi. And we remember, hopefully, that an even multiple of pi is going to end up facing in this particular direction to the right. And then if we have 0 as the R value, that means we're not going to go out any distance. So this point would simply be located at the origin, or what we refer to as the pole. Okay, so hopefully now you have a little bit of an idea of how to find and locate these points. R is the directed distance that we go out. Theta is the directed angle that we rotate around. And keep in mind, if it's positive R, we're going to go in the direction of the angle. And if R is negative, we're going to go in the opposite direction of the angle.